What if I told you the best way to find security holes in software wasn't to attack it head-on, but to trick it into revealing its own flaws? Well, that's the kind of mind-bending idea behind a new technique called Fuzztruction. And believe me, it's really changing the way we think about software security. Let's dive in and see how this thing works. So think about it. Every single day, you trust software to handle some incredibly complex stuff. Encrypted messages, compressed files, you name it. These aren't just simple text documents, right? They're these intricate structures with a ton of rules. And that, right there, that's where the danger can creep in.
So that begs the million-dollar question. How do we actually know the software we rely on is safe? I mean, how do we find those little hidden cracks in the armor before, the bad guys do?
Okay, so to really get why this new technique is such a big deal, we kind of need to back up a bit and look at how things are usually done. We'll start with the dangers lurking inside our software. The main tool in the toolbox for this is something called fuzzing. It's basically a stress test for software. You just throw a whole bunch of garbage at a program, random, broken, unexpected data, and you just wait. You wait to see if it crashes. A crash is like a big red flag that says, hey, there might be a security problem here.
But, and there's always a but, right? As powerful as fuzzing is, it has this one huge weakness. And that weakness is the exact problem Fuzztruction was built to solve. The easiest way to think about it is like this. Traditional fuzzing is like trying to guess a super complex password just by mashing random keys on your keyboard. Sure, you might get lucky and guess password 123, but you're never ever going to randomly type out a super long, complex password with symbols and numbers. No way. The same thing is true with software.
So you can see the problem here. With simple stuff, a little random tweak might get past the bouncer at the door and let you test the code inside. But with something really complex, like an encrypted file, any random change, even one tiny bit, and the program just looks at it and goes, nope, this is garbage, and slams the door shut. The fuzzer never even gets inside to test the important parts.
And look, people have tried other things, right? There's all this super heavyweight analysis. But honestly, it's just way too slow. Or you need a human expert to sit there and write out all the rules for the data, which costs a ton of time and money. And even then, they really struggle with things like cryptography.
Okay, so this is where things get really, really cool. Fuzztruction comes along and just flips the entire problem on its head. And this right here, this quote, is the key. It's the whole idea in a nutshell. Forget about trying to break the message. What if you could get the messenger to screw up just a little bit? And that is the absolute genius of this technique. Instead of messing with the final data file, Fuzztruction goes after the program that creates the file in the first place. Let's call it the generator. It introduces tiny little flaws there, creating a semi-valid file that looks right but is secretly wrong, tricking the target program into letting its guard down. So here's how it plays out. First, the tool scans the generator's code. It's looking for just the right places to inject a tiny, tiny fault. Then this, let's call it faulty generator, spits out a file, and to the outside world, this file looks perfect. It sails right past all the initial security checks, but hidden inside is this subtle little flaw like a Trojan horse, just waiting to trigger those deep, hard-to-find bugs.
Okay, so that all sounds great in theory, right? But does it actually work? Well, the researchers put Fuzztruction to the test, and wow, the results are kind of staggering. Let's look at the numbers.
First up, code coverage. That's basically just a fancy way of saying how much of the program did we actually manage to test. And right away, Fuzztruction gets into 21% more of the code on average than the best of the best fuzzers out there. That's a huge deal. But check this out. Remember those really hard targets, the ones with all the complicated cryptography that just block everything else? On those, Fuzztruction got a whopping 70% more code coverage. 70%. That's not just better, that's a total game changer.
But okay, getting to more code is great, but what's the point? The point is finding bugs. And did Fuzztruction deliver? It found an incredible 151 unique crashes.
I mean, just look at this chart. The other top-tier fuzzers, they found some bugs, sure. 25, 37, 31, not bad. But Fuzztruction, 151. It found more crashes than all of them combined. That's not just a small step up, that is a massive leap forward. And these aren't just theoretical crashes on a researcher's laptop. We're talking about real-world impact. So far, 27 of these bugs have been reported to the developers, and 4 of them were serious enough to get their own official CVE numbers. Those IDs they give to actual confirmed security vulnerabilities. This stuff is getting fixed right now because of this research.
So what's the big takeaway from all this? Why does this matter so much? Let's wrap it up.
Really, when you boil it all down, Fuzztruction automates expertise. Think about it. All the incredibly complex knowledge about how to create a valid encrypted file or a compressed archive, that's usually locked up inside a program's code or in the brain of a highly paid expert. Fuzztruction just pulls that knowledge out automatically. It's a totally different way of thinking. You're not starting from scratch. You're just using the domain knowledge that's already there, baked right into the software. This means you don't need a human expert to guide it, and you don't need to do that super slow, complex analysis. And the result? You find these deep, nasty bugs in complex systems that all the other tools just completely miss. And to me, that's the real magic here. It just goes to show you that sometimes the biggest breakthroughs come when you just flip the problem around and look at it from a completely different angle. It really makes you wonder, right? What's the next huge security breakthrough that's just hiding in plain sight?